So yesterday we were talking about some examples. Now how many of you have done all those structures? There is no reply from you all. Total silence. Asta, have you done all those structures?
No, sir.
Oh. Mesha, have you done all those structures?
Good evening, sir.
Good evening, Mesha. Have you done all those structures, Mesha?
Yes, sir. Actually, I couldn't do the last two ones, HNO3 and
No, I am not getting what you are asking me. HNO3. Can you show
sir,
me?
I have completed HClO2, HClO3 and HClO4.
Yeah.
But I have some problem in H2SO4 and H2SO3.
Can you show me HClO3, HClO4 and HClO2?
I send it to the WhatsApp.
Yeah, you can WhatsApp me. HClO2, C Mesha. I'll explain that. HClO2. So obviously central atom will be Cl. Central atom will be Cl. Now we'll take one oxygen atom that will be having 2 unpaired electron, one hydrogen atom that will be having 1 unpaired. In this way unpaired electron of hydrogen get paired, and like this unpaired electrons of oxygen will also get paired. Now what about Cl? What about Cl? Cl will be having completely filled octet. Fine. Now see, octet of Cl is over. Now what else can be formed? One more oxygen is there. That oxygen will be having 2 unpaired electrons and 4 paired electrons. Now this will be one-sided sharing. So HO, this is fine, Mesha. This is also fine, but here it will be coordinate bond. Here it will be coordinate bond or dative bond, but you wrote covalent bond, so that's not correct. Fine. So this part is not correct. It should be a coordinate bond. Here you wrote double covalent bond. Is it okay?
Yes, sir.
And it is monobasic acid. Why it is monobasic acid? Because one OH is there. In HOCl, I'll tell you one more point. HOCl, what is the oxidation state of Cl? This is 1 plus, this is -2, and this is unknown that you have to calculate. So X will be equal to +1. What about here in HClO2? F1 plus X minus 4 is equal to 0. So X will be +3. X will be plus 2. I have written HOCl, what they will be writing? OCl minus. One more very important point, since we discussed this now. See, nowadays what they are doing for this corona, they are spreading, they are spraying some liquid now. What that liquid is? That liquid is this one. What that liquid is? This one, hypochlorous acid. Hypochlorous acid. So see, they can ask you this too now. Hypochlorous acid, that liquid which they are spraying in public places to sanitize, that is hypochlorous acid, HOCl. That is HOCl. Now see, this is plus 3. Now see, HClO, HClO3. HClO3. Next is HClO3. See, 1O, 1H, this is paired. Now this will also get completely filled or paired electrons. Fine. What about Cl? Cl will be having completely filled octet, but still two more oxygen atoms are there. One oxygen will be placed here and will form coordinate bond with this. Another oxygen will be placed here and will again be forming coordinate bond with this. So HOCl, coordinate bond, one lone pair. Here two lone pairs were there. So in this way you can draw, all these structures. Here see, Mesha, what I told you in HOCl, how many, what will be the valency of Cl here? That is 1. Here it is 2 and 1, 3. Here it is 2, 4 and 1, 5. Here HClO3, 1 plus X minus 6. 1 plus X minus 6 is equal to 0. So X will be plus 5. So here the oxidation number of Cl is plus 5. Now this was HClO5. Now I will go to the next one. HClO4. Cl, again 7 electrons, 1 unpaired. This will be oxygen and one more hydrogen, paired, octet completed. Now here octet completed. Now 4 oxygen, 1 is already written, 3 more are there. So 1, 2, 3. These all the 3 oxygen atoms are having incompletely filled octet. To complete that incomplete octet, this lone pair of electron of Cl will be shared unequally. Here also it is like this, here also like this. So HOCl, coordinate bond, dative bond. So in this way you will be drawing structures. But in your books, what it is written, if it is written like this, then also please don't write that, because it won't be possible. That's not the right one, that's the incorrect one. So HClO3, HOCl. So fine, this all is done. Fine, at least you tried. That's the most important thing. Learning by making mistakes, then you will never forget. Without learning, you can never remember. So if you are making mistake, fine, but in this way only you can remember. Now I'll be drawing the next structure, H2SO3. See, sulfur is having 6 electrons. One oxygen will be having 2 unpaired electrons. Hydrogen will be having 1 unpaired. Another oxygen will also be having like that. One hydrogen will be having 1 unpaired electron. This is paired. This is also paired. Now see, oxygen. This oxygen will be having completely filled octet. This oxygen will also be having completely filled octet. 2, 4, 6, 8. 2 bond pairs plus 2 lone pairs. 2 bond pairs and 2 lone pairs. Oxygen is having 2 bond pairs and 2 lone pairs. Now see, what about the sulfur? Sulfur is having completely filled octet, 2, 4, 6, 8. But still one oxygen is missing. That you can write here or here. Anywhere you can write. And in this way, all unpaired electrons of oxygen, or you can say incompletely filled octet of oxygen, will be completely filled. So C, S, O, H, OH and a coordinate bond, dative bond. After completing octet, as I already told you, after completing octet, no other bond can ever be formed except the coordinate bond, except the dative bond. So here dative bond or coordinate bond is formed. Is it okay? See, this is dibasic acid. This is dibasic acid. As in chapter 1, some basic concepts of chemistry, there I told you about equivalent weight. So suppose if you will be writing equivalent weight of H2SO3 sulfurous acid. What is its name? Sulfurous acid. So see, what is the molecular weight of it? Molecular weight upon, since it's an acid now, so it's basicity. Acids will have basicity and bases will have acidity. Molecular weight. See, this is 32 and 16 threes are 48. 48 plus 32 will be 80 and this is 82. 2 plus 32 plus 48. 16 threes are 48. 8 to 10. 12 to carry over 1. 82. 82. Basicity here, as I already told you, 2. Why 2? Because 2 OH groups are there. Why 2? Because 2 OH groups are there. Why 2? Because 2 OH groups are there. Why 2? Because 2. Why 2? Because 2 OH groups are there. This sulfurous acid is having 2 replaceable hydrogen atoms. This sulfurous acid is having 2 replaceable hydrogen atoms. This hydrogen is replaceable and this hydrogen is also replaceable. Those hydrogens which are there in the form of OH. Those hydrogens which are there in the form of OH are polar, are easily replaceable. Because the difference in electronegativity between an O and H will be very, very high. So this H will be polar and can be replaced. So only those H atoms which are there in the form of OH are replaceable. If H is not there in the form of OH, then will never be replaceable. So this H and this H, these two H are replaceable hydrogen atoms. So it will be dibasic in nature. So molecular weight 82 will be divided by 2, that would be 41. So equivalent weight 41. Of sulfurous acid will be 41. So in this way you can calculate it. That's very, very important, fam. You should remember this all, and in equilibrium, in almost every chapter, this all you will be getting there in organic chemistry also, 12th class, 6th A group. There we won't be discussing this all. So you need not to do this all. There obviously will be, this is Couper's graphical formula and this is Lewis electron dot structure. So this all we will not be discussing about the basicity. This all lone pair, bond pair, everything we won't be discussing there. This all will be there. Fine. So this is H2SO3. Now we'll talk about H2SO4.
Yes, sir.
Sulfuric acid. Sulfuric acid. See, sulfur is having 6 electrons. If your 12 points are clear, then you need not to think. You'll be writing very fast. But if you have not done those 12 points, then will be a problem for you. Then I can't help you. See this H, this H. Now this sulfur is having completely filled octet. What about oxygen? Oxygen will also be having completely filled octet. All unpaired electrons will get paired. Now see this sulfur OH. The sulfur OH. H. Now see, this sulfur is having two lone pair of electrons, and you have written only two oxygen atoms. Two more oxygen atoms are there. One you will be writing here. In this way, octet will get completed. Another oxygen you will be writing here. There also octet will be completed. Now see, coordinate bond one here and one here. This is Lewis electron dot structure. This is Couper's graphical formula. This is also dibasic acid. This is also dibasic acid. Now its equivalent weights. This is sulfuric acid. Equivalent weight of sulfuric acid will be equal to molecular weight upon basicity. Molecular weight 64 plus 32. 96 plus 2, 98. So 98 upon 2, that is 49. 98 upon 42, that is 49. 64 plus 32, 96 plus 2, 98. So this is about sulfuric acid. So they can ask you this all. Here they can ask you oxidation number na, H2SO4. What is the oxidation number of sulfur? 2 plus X minus 8 is equal to 0. So X will be plus 6. Now in H2SO3, 2 plus X minus 6 is equal to 0. So X is equal to plus 4. This is oxidation number, and valency will be 4. Here oxidation number plus 6 and valency will be, here oxidation number plus 6 and valency will be 6. Which is having higher oxidation number? Higher the oxidation number, more will be the acidic strength. More will be the acidic strength. So this will be stronger acid, and this will be in compared to that weaker acid. Higher the oxidation number, greater will be the acidic strength. Since in H2SO4 sulfur is having plus 6 oxidation state, and in H2SO3 sulfur is having plus 4 oxidation state, so since the oxidation state there in H2SO4 is little higher, so will be a stronger acid, because more the oxidation number, more will be the acidic strength. So in this way you can calculate this all. Harshni, how many of you wrote all these structures? How many of these structures you have written? What I gave you yesterday?
4, sir.
4. So which you have not done? I think I gave you 5 now. So which was missing? Where you were having issue?
HClO4.
ClO
4.
4. HClO4. So that you were there now when I was explaining HClO4?
Yes, sir.
Okay, fine. This was HClO4. So it's not easy one, it is one of the difficult most topics. So I'll discuss some more structures: H3PO2, H3PO3, H3PO4. It's a very big part and very important too. See, H3PO2, theoretically you can draw many structures. This is phosphorus. One oxygen will be having two unpaired electrons. One hydrogen will be having one unpaired. In this way, all unpaired electrons of hydrogen as well as oxygen will get completed, and the octet of oxygen also will get completed. Now see, you can draw this structure also. One more oxygen, one more oxygen, one hydrogen. So now see this oxygen again will be having completely filled octet. What about H3, H2 is used, O2 is used, P is used, one more hydrogen is there. That will be done like this. Now see, this phosphorus will be having 2, 4, 6 and 8 electrons. So P, OH, OH, H. Is it okay? Is this the right structure?
Yes.
Asta, it is right? Mesha, is it right? Harshni,
Yes, sir.
is it right, Harshni?
Yes, sir.
No. Asta and Harshni, you should not say like this. Why? Because you should know that H3PO2, here what you have written? You have written dibasic acid. What have you written here? Dibasic acid. But
Dibasic acid.
H3PO2 is not dibasic acid. H3PO2 is not dibasic acid. H3PO2 is not dibasic acid, it is monobasic acid. So theoretically this structure is correct, but practically it's wrong. It's wrong. See, one compound can have more than one structure and any one of them will be right. How you will come to know whether it is right or wrong? You should know this point, that H3PO2 is monobasic acid. So here you have written two OH groups, that is dibasic acid. So that's wrong. It's not correct. So you should know this. So now draw like this. Phosphorus is having 5 electrons. Oxygen will be having 2 unpaired. Hydrogen will be having 1 unpaired. This is now paired. This also get completed. H3PO2. 1 hydrogen will be written here. 1 hydrogen will be written here. In this way, all unpaired electrons of hydrogen will get paired. What about phosphorus? What about phosphorus? 2, 4, 6 and 8. Octet is complete. But one more oxygen is missing. So that oxygen will be written here. No other structure you can draw for this. No other structure you can draw for this. So P, 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 OH, H, H and a coordinate bond. This is H3PO2. It is monobasic acid. So this is the right structure, POH, H. Fine, that's already written here. That's already written here. So need not to draw this structure. It is monobasic acid. It is monobasic acid. So equivalent weight is equal to molecular weight upon 1. What is molecular weight? 31 plus 3, 34, and this is 32. 34 plus 32 will be 66. 66 divided by 1. 31 plus 3, 34 plus 32. 34 plus 32 will be 66 divided by 1. So what molecular weight this H3PO2 is having, same molecular weight, will be the equivalent weight. This is about H3PO2. Mesha, is it okay?
Yes, sir.
Astha, Harshni? All these points again will be there in
Yes,
12th
sir.
class part also. Fine. So there that's very, very important, and from this questions they will be asking. This equivalent weight concept will be used there in your mole concept also, na? Solution chapter also there. Normality, for normality,
Yes, sir.
equivalent weight is required now. So without knowing this all, how you can solve all those numericals? So now I'll be going to H3PO3. H3PO3. See, phosphorus. You can draw it like this too. You can draw it like this too, but that's wrong. That's wrong, because according to this structure it will be tribasic acid, but experimentally it is proved that it is not tribasic acid, it is dibasic acid. Now see, I'll be doing in different way. I'll be writing this structure in a different way. I don't know what happened, why I am not able to write on this part. What I'll do, I'll share the new screen. Then also it is same. P, as I told you, it is dibasic acid. So dibasic. Fine. Now I'll be doing reverse way. HS3, 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 H3, PO3. See now how many electrons phosphorus is having? They are in the valence shell. 5, 6, 7, 8. All 8 electrons are over now. So now it can form only coordinate bond. So that coordinate bond will be here. That coordinate bond will be here. So this will be the structure OH, OH, OH. Just a minute, I'll bring other pen, digital pen, so that I can write it properly. Just a minute. There can be some battery issue. So now this POH, this is also not able to miss. Some other problem is there. Okay, fine. So POH, POH, OH, H and C. This phosphorus is having how many electrons? 5, 6, 7, 8. Now after completing octet, if any other bond can be formed, that can only be a coordinate bond, dative bond or bipolar bond. So that's here. After completing octet, no other bond, as I told you yesterday too, that no other bond can ever be formed except the coordinate bond or dative bond after completing octet. So this is H3PO3. Now see H3PO4. Now see H3PO4. Now in case of H3PO4, it is tribasic acid. This all theory you should know. This P is having 6, 7, 8 electrons. So now its octet is over. Only coordinate bond can be formed. So that's all. This is tribasic acid. This is tribasic acid. So molecular weight upon 3 is equal to equivalent weight. Molecular weight 16 fours are 64. 64 plus 34, 98. 98 divided by 3. This will be equivalent weight. This equivalent weight will be very important to calculate. This equivalent weight will be very important to calculate the normality of the solution. So that's why it's so important. So this is all for H3PO3. So many structures we have done. All these structures are very, very important. We should know all these structures, then only we can handle chemistry easily. This is very, very, so I'll be giving you some more structures for homework so that you can. We have done HNO2, HNO3, H2SO4, H2SO3, HClO2, HClO3, HClO4, HOCl. This all is done. So now what else I can give you? CO2, CO, then Cl2O7, 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 Br3O8, then P2O3, P2O5, 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 P2O5. This all we should know. I wrote there HOCl, but in exam they will be writing OCl minus. I have written HClO2. In exam they will be writing ClO2 minus. I wrote HClO3, they will be writing ClO3 minus. I wrote HClO4, they will be writing ClO4 1 minus. Fine. So for this H3PO2, 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 H3PO3, one very important point I'll tell you here, especially Astha, Mesha, you can have some issues because you are studying this all first time there in your life, but Astha and Harshni, you might have studied this all. So see, here, if you'll be taking out 3H, then what you will be getting? PO3, this here, troubling. PO2 3 minus. Here PO3 3 minus. This is PO4 3 minus. This is fine. Why? Because this H3PO4 is having 3 OH groups, and all the 3 hydrogens, since are there in the form of OH, so are replaceable. And when all the 3 hydrogen atoms will be lost, 3 minus charge will get developed on this PO4. So that's okay. What about this one? This is dibasic acid. This is dibasic acid. This is dibasic acid. This is dibasic acid. This is dibasic acid, so it can't donate 3H. H3PO3 can't donate 3H plus. Why? Because it is dibasic now, so can donate only 2H plus. So will form HPO3 2 minus. Mesha, are you getting my point?
Yes, sir.
Fine. Harshni, Astha?
Yes, sir.
Yes, sir.
Is it clear? Since it is not tribasic acid, now it is dibasic acid, so only 2H can be lost. So if 2H are lost, then it will be forming HPO3 3 minus. This question was there in IIT, in NEET or IIT, I am not sure, but was there. So that's very important. So this won't be possible. This is possible, but this won't be possible. HPO3, if they have, they might be asking you which is not possible. A, PO3 3 minus, HPO3 2 minus, PO2 3 minus, or PO4 3 minus, like they will be asking you. What about this one? This is monobasic acid now. This is monobasic acid, so can lose only one H. So H3PO2 losing only one H plus, then what you will be getting? H2PO2 1 minus only. This PO2 3 minus won't be possible. It is monobasic acid, so can lose only one H plus. This is dibasic acid, so can lose only 2H plus. This is tribasic acid, so can lose 3H plus. So H2PO2 minus will be possible, but PO2 3 minus won't be possible. And if 2 electrons are lost from this, if 2 hydrogens are lost from it, then if 2 hydrogens are lost, then it will be HPO2 2 minus. This will also not be possible. This will also not be possible because it can't donate 2H plus. Why it can't donate 2H plus? Because 2 OH are not there. Only one OH is there, and that is only one hydrogen which can be replaced. That is the only one hydrogen which can be replaced. I'll go back again. See here, listen very carefully, that's very important. This P and OH is there, and this hydrogen can be lost. What about this H? This H can't be lost. Why? Because it is not polar. This hydrogen can't be lost. Why? Because this is not polar. How can you say it is not polar while this was polar? This was polar because attached with oxygen, and oxygen is highly electronegative. So this will partially positive charge and this will partially negatively charge. What about this phosphorus and hydrogen? Phosphorus is not so electronegative. So this pH bond will not be polar. This H will not be partially positively charged. So will not be losing. This phosphorus will not be losing that H plus. Like this hydrogen is also not polar, so will not be lost. Only one hydrogen will be lost. Is it okay? So this is what the point which I was trying to explain you, and is very, very important. Questions they might be asking you like this. So now P2O5 Cl2O7. First I'll tell you P2O3. Fine. P one more P I'll be taking here. Now see, this phosphorus, this oxygen will overlap this unpaired electron, and this unpaired electron of oxygen will overlap this unpaired electron. In this way, this P will be attached with O, and O will again be attached with oxygen, phosphorus. This oxygen will be having two lone pairs. This oxygen will be having two lone pairs. This oxygen will be having two lone pairs, and still two more oxygen atoms are there. These two unpaired electrons will overlap these two unpaired electrons of oxygen. In this way, octet of oxygen will get completely filled. These two unpaired electrons, what I'll do, I'll write that electron here. So now these two unpaired electrons will overlap these two unpaired electrons of oxygen. In this way, all unpaired electrons of oxygen will get completely filled. What about the phosphorus? Sorry, what about this phosphorus? This 2, 4, 6 and 8. This phosphorus 2, 4, 6 and 8. So we will be writing it like this. P2O3. What it is? P2O3. This is P2O3. Many more structures are there. What we are able to do, we'll do it here, and what rest that you can do there at home, and tomorrow you can show me in class only. If you'll show me, that will be good enough, because if you'll be sending me prior to class, then I won't be remembering that what have you done. But if in class you will be showing me, that immediately I'll be helping you that what mistake you have done, and accordingly. So making mistake is not a big deal, but you should learn from your mistake. That's important one. Fine. If we know everything, then obviously then why we will be